Obesity is closely linked to a chronic, low-grade inflammatory state that underlies many of its most damaging complications, from insulin resistance and cardiovascular disease to liver dysfunction and cognitive decline. This persistent inflammation doesn't arise simply from the presence of excess fat, but from the complex and dysregulated behavior of immune cells within metabolic tissues, particularly when autophagy is impaired. As research continues to reveal, defective autophagy in these immune cells plays a critical role in promoting and sustaining this harmful inflammatory environment. In a healthy state, autophagy acts as a crucial regulator of immune function. It keeps inflammation in check by clearing damaged cellular components, removing toxic protein aggregates, and regulating cytokine production. In immune cells like macrophages, dendritic cells, and T cells, autophagy is essential for maintaining proper responsiveness without triggering unnecessary or prolonged inflammatory responses. By degrading damaged mitochondria and preventing the leakage of reactive oxygen species, ROS, autophagy helps prevent the activation of key inflammatory pathways such as NF-B and the inflammasome system. However, in obesity, this finely tuned balance is disrupted. As adipose tissue expands, it becomes hypoxic and stressed, attracting immune cells, particularly pro-inflammatory macrophages, that begin to infiltrate fat depots. In these immune cells, autophagy often becomes dysfunctional, either through suppression of autophagic gene expression or impaired autophagosome-lysosome fusion. This leads to the buildup of damaged organelles and pro-inflammatory signaling molecules, fueling a cycle of cytokine release, immune cell recruitment, and further tissue stress. The consequence is a self-amplifying loop. Excess fat causes immune dysfunction, which in turn exacerbates inflammation, further damages tissue, and impairs metabolic signaling. In particular, chronic inflammation directly interferes with insulin sensitivity, partly through the release of TNF-A, IL-6, and other cytokines that block insulin receptor pathways in liver, muscle, and fat cells. Over time, this systemic inflammatory burden contributes not only to metabolic syndrome, but also to a heightened risk of autoimmune conditions, neurodegenerative diseases, and even certain cancers. Yet, there is a powerful opportunity within this pathology. Because autophagy is a modifiable process, restoring its function in immune cells offers a compelling strategy for reducing obesity-induced inflammation. In animal studies, boosting autophagy in macrophages has been shown to reduce pro-inflammatory cytokine production and shift immune cell profiles from inflammatory, M1, to anti-inflammatory, M2, states. This not only alleviates local tissue damage in fat and liver, but also improves whole-body insulin sensitivity and glucose metabolism. Lifestyle factors play a significant role in modulating immune cell autophagy. Intermittent fasting, caloric restriction, and endurance exercise have all been shown to enhance autophagic activity in both immune and non-immune cells, helping to reduce inflammation at its root. Certain nutrients and natural compounds, such as omega-3 fatty acids, curcumin, and polyphenol, may also support this pathway, offering additional therapeutic leverage. Even moderate weight loss itself has been shown to partially restore autophagic capacity in immune cells, leading to measurable reductions in circulating inflammatory markers. Importantly, this emerging understanding of autophagy's role in immune regulation challenges the outdated view of fat as merely inert storage. Instead, it paints a picture of adipose tissue as an immunologically active organ whose health depends on cellular turnover and internal housekeeping. When autophagy fails, immune cells become not just responders to damage, but contributors to it. This means that reversing autophagic dysfunction isn't just about improving cell health, it's about restoring peace in an inflamed metabolic environment. In conclusion, defective autophagy in immune cells is a driving force behind the chronic inflammation associated with obesity. Yet this dysfunction is not permanent. Through lifestyle interventions and possibly targeted therapies, autophagic pathways can be reactivated, reducing inflammation and helping restore metabolic balance. This reveals a hopeful path forward, not just in managing obesity, but in addressing the deeper cellular dysfunctions that fuel its most serious consequences. In the fight against inflammation-driven disease, autophagy may prove to be one of the body's most powerful and natural allies.